All right. So, guys, we're basically going back and reviewing everything that we really just started the year with. So, we're about to take the next 2 weeks to 3 weeks talking about linear relationships. Okay. All of it should be reviewed. All of it you should be familiar with. Like, I'm literally using the exact same presentation right now that I used earlier on in the year. Okay. So you'll see me going a little quicker, but what I need you to do is some of you did not understand proportional relationships, slope and y-intercept. That stuff did not stick with you. So I need you to make sure you're asking questions, okay? Because we're going over this for a reason. We're going thank you, Mia. We're going back over this for a reason because it is one of the most what's the word? Tested topics. And it's the thing that's going to carry on into Algebra 1. So today we're talking about proportional relationships, okay? Proportional relationships. So what is a proportional relationship? So it's a relationship between X and Y when the ratio between X and Y are the same always. Okay, so hopefully this is looking somewhat like, okay, I remember ratios between Y and X. So they're the same always. So no matter what 2 points I picked on my graph or on a table, they would have the same ratio between Y and X. They would have the same constant rate. So what's a proportional relationship? It's a relationship between X and Y where the ratio between them are always the same. Always the same. So for a proportional relationship, the equation I use is y equals kx. Y equals kx. And if we remember, this k just stood for the slope, basically. This is our slope. But the proper word we use is the constant of proportionality. The constant of proportionality. This tells me at what rate of change the relationship is between X and Y. What you should notice and this should look familiar to is the y equals mx plus b. But what's different is the plus b part. Because for a proportional relationship, the y-intercept is 0. The y-intercept is 0. So there are a couple of big star important things that we need to remember about proportional relationships. That the k was just the slope or the constant proportionality. And I know that because the coefficient of x is the number multiplied to x. And that a proportional relationship always has a y-intercept of 0. A proportional relationship always has a y-intercept of 0. So if I'm looking at this graph right here, how can I tell if it's a proportional relationship? What is the big key thing that I can look at and be like, oh, that's proportional?
It passes through the origin.
Perfect. It passes right through the origin, telling me that the y-intercept is 0. So since it goes right through that origin, this tells me the y-intercept is 0. And so since the y-intercept is 0, I know this is proportional, telling me that the ratio between y and x should be the same. So what do I mean by that? If I have a point here, this point right here is 2, 4. And this point right here is 3, 6. Well, if I did my proportion or a ratio of y over x, and I take this first x and y and do 4 over 2, well, 4 over 2 equals 2. If I looked at this x and y and did the same thing, 6 over 3, that also equals 2, because the ratio between y and x should be the same. Therefore, telling me that the equation to this graph is y equals 2x. And I could also just find the slope, rise over run. It's rising 2, running 1. So the rate The constant of proportionality is 2. So usually I would have a handout right now and we would be doing this for a handout, but can someone unmute and tell me if this top graph is proportional? Why or why not?
No, because it doesn't pass through the origin.
Perfect. And the y-intercept here is 4. So since this y-intercept is 4, I know this is non-proportional. That doesn't mean we can't find the equation, right? The b is 4. Well, I could do rise over run to find my slope. Okay. So I could figure out my rise over my run. 1, 2, 3, 4, 5. I think that was actually 6. No, that's 5. And then 1, 2. So 5 over 2. So my slope is 5 over 2. So I could still find my equation. Y equals mx plus b. It'd be y equals 5 over 2x plus 4. Someone different, can you unmute and tell me, is this bottom graph proportional?
It is,
Perfect. And how do you know?
because it passes through the origin.
Perfect. Perfect. It passes through the origin, telling me it has a y-intercept of 0. So because of that, I know this is proportional. But remember, we're not stopping just at is it proportional or not. We're also needing to find the slope. Okay, so you could take a point and just do the proportion of y over x, or you could take 2 points and do your rise over your run. 1, 2, 3, 4 is my rise. 1, 2, 3, 4, 5 is my run. And this line is going down from left to right, telling me it's a negative slope. So my k, or my m here, is negative 4/5. All right, I'm moving on from graphs. So if you have a question, please unmute. If you have a question, please unmute. All right, so looking at tables. So again, this should look very familiar because we already did this whole entire presentation a few months ago, okay? So when I'm looking at tables and I wanna see if they're proportional, I could see if it shows me the y-intercept. For example, 0, 0, that's the origin. So this already tells me it's going through the origin, telling me this was proportional. But what if this wasn't here? To figure out if it's proportional, I need to see if the ratio between y and x are the same. So y over x, 25 over 5, well, that equals 5. 35 over 7, 35 over 7, that equals 5. 40 over 8, 40 over 8, that ratio equals 5. 100 over 20, well, that ratio equals 5. Because they all equal 5, my y over x for each one equals 5, I know that this is proportional because the ratio is the same for each y and x. So that tells me also my equation is y equals 5x. Okay, now for the sake of time and me wanting to do the actual assignments with you, I'm gonna look at these tables real quick. Give me 1 second, guys, 1 second. By now, though, hopefully you looked at the tables and kind of try to determine to yourself whether or not they were proportional. So I'm looking at the ratio between y and x. 6 over negative 4. That is negative 3 over 2. Here I have negative 3 over 2. I'm just going to reduce these into just fractions. Well, I'm pretty sure that's negative 1.5. So we can go ahead and put this is negative 1.5. This is negative 1.5. Negative 7.5 over 5. Is also negative 1.5. And negative 9 over 6 is also negative 1.5. So since they all have the same ratio, I know that this is proportional. And because the ratio between them is 1.5, I know that my equation is negative 1.5x. Now, some of you may be wondering, could you do x over y? You could, but that won't give you the ratio of y over x, which is the k value. Because y equals kx. If I wanted to find k, I would divide both sides by x. So y over x equals k. This is how I find what my k value actually is. So really quickly, look at this table and determine if it's proportional or not. And in the chat, private chat me, yes or no. Is it proportional? Yes or no. So look at the ratio between y over x. And you might only have to do a couple of them to figure out the answer. So please, everyone participate. You're trying to see if that bottom table is proportional, yes or no. Is that bottom table proportional, yes or no? And private message me in the chat. Not my pen. All right, so when I do this, 11 over 3, let's see, is 3.6 repeating, but 8 over 2 is 4. So automatically, I already know this is not proportional because the first ratio did not work out. So this table is non-proportional. Awesome job, guys. Good, good, good. Thank you for your participation. All right. So the last thing we want to look at are word problems. We want to determine if these word problems are proportional or not. Well, remember, for something to be proportional, it needs to have a y-intercept of 0. For something to be proportional, it needs to have a y-intercept of 0. So if I was writing out my linear equation, y equals mx plus b, hopefully everyone remembers that m is slope and b stands for the y-intercept. Okay, hopefully this has kind of been ingrained into you. When I'm looking for my coefficient of x, my slope, my constant proportionality, if it's proportional, I'm looking for words like per and each. So I went 60 miles per hour on the highway. That's talking about slope. I'm going 60 miles per every 1 hour. So that tells me my slope. The y-intercept is like that one-time fee. That thing I'm only going to do one time, my initial amount, how much I start with. Those are the keywords for the y-intercept. So I'm looking at this first example. John owns the company Rent a Bike. He charges $2 an hour to rent one of his bikes. Is this proportional? Well, if I'm renting a bike $2 per hour, that's constant. I'm constantly being charged $2 each hour. So that is proportional. This would represent my k, or my slope. So my equation will be y equals 2x. And it's proportional because the y-intercept is 0. There's no additional fee. There's no one-time payment. There's no deposit. So this is proportional. On my second example, John owns the company Rent a Bike. He charges a security fee of $20. Well, before I even keep reading, how many times am I going to pay $20? Only one time. That's a one-time fee. This is a one-time fee. So therefore, that's my y-intercept. In an hourly rate of $2. So each hour, I'm paying $2. So there's my slope. Telling me this is not proportional. Why? Because it has a y-intercept of 20, not 0. So my equation is y equals 2x plus 20. Where 2 represents my slope and 20 represents my y-intercept. So literally, if you took your notes back in the beginning of the year, you probably have those same literal notes because it's the same presentation. So let's look at this scenario real quick. And I don't know if anyone remembers the trick here. So let's look at this scenario, and in the chat, I want you to type me yes or no if it's proportional or not. And I want you to type me what the equation would be. Judas bought peaches online for $2.30 per pound and a delivery charge of 30 cents per pound. So use your keywords and determine, is that proportional? Type it in the chat. Type it in the chat. Is this proportional? And what would the equation be? All right, so this was a trick one because you had to look at those keywords. Most of the time people see two numbers. Oh, there's two numbers here, so it's not proportional. There's a y-intercept somewhere. But let's read it. Judas bought peaches online for $2.30 per pound, and a delivery charge of 30 cents per pound. They both are being charged per pound. So they're both the slope, or both the constant proportionality. So I could just add them together. Giving me the equation y equals 2.60x, meaning they are proportional. Because there's not a one-time fee or an initial amount. Good, I'm liking these explanations I'm getting in the chat. Awesome, guys. All right, let's look at this last one. Jonathan gives hay rides at the local farm. He charges $2.50 per hour and $10 for a helmet. Determine if that is proportional or not, and write the equation in the chat for me, please. Determine if that is proportional or not, and write that equation in the chat. Is this proportional? And write that equation in the chat. Beautiful, beautiful, beautiful. So what I'm getting in the chat is not proportional because it has a one-time fee of $10. So this 10 represents the y-intercept. And 250 per hour, that's my slope. So the equation would be y equals 2.50x plus 10. And because there's a y-intercept of 10, it is not proportional. It's just non-proportional, okay? Good job, good job, good job. All right, we're not doing this. This was for last year where we could do group activities and stuff like that.